Hi there, so today we're having a look at Unit 8.6 angles in quadrilaterals. Our objectives for today to use the rule for the sum of angles in a quadrilateral and to identify and name special types of quadrilaterals. Before we start, let's check our prior knowledge. So we should know the angle properties of the three types of triangles: scalene, isosceles and equilateral triangle. We should also know the properties of straight lines and points. So angles on a straight line add up to 180 degrees and angles around a point add up to 360 degrees. We should know the total interior angles in a triangle. So angles in a triangle add up to 180 degrees. And we should know the definition of an interior and an exterior angle. So an interior angle, the angle inside the shape. The exterior angle, the angle formed when we extend the side of the shape back to the original shape. And we should know that an interior angle and an exterior angle will add to 180 degrees because they are angles on a straight line. Okay, make sure you're happy with that before you start. If not, you need to go back and have a look at the previous lessons. Okay, so today we're going to have a look at a quadrilateral then. So a quadrilateral, a four-sided shape. So we need to know the sum of the interior angles in a quadrilateral. Well, to help us to work that out, we can split our quadrilateral into two triangles. So if we draw a diagonal line from one side to the other and split that into two triangles, we've got that first triangle there, which I've labelled ABC. We know the total interior angles in a triangle add to 180 degrees. We've then got our second triangle, the green one, which I'm going to call D, E and F. And again, the total interior angles in that triangle must also add to 180 degrees. So if we've got all of the angles here 180 degrees and all of these are 180 degrees, we can see that this is 1, 2, 3, our four angles in our quadrilateral. So 180 plus 180 is 360 degrees. So the total interior angles in a quadrilateral is 360 degrees. Okay, make sure you've made a note of that. So again, anything in a green box is an important note that you need to know. So we're going to use that fact today then to help us to find some missing angles in quadrilaterals. So again, we'll do some examples first. So here we've been given a quadrilateral. We've been told three of the angles inside our quadrilateral. We need to find the fourth. So we know that the total adds to 360. So if we add up all of the ones that we know and take that from 360, we should be able to find the one we have left. So 360 minus the 138 plus 42 plus 42. Now if I add all of those together, that comes to 222. So 360 minus 222 means that A was 138 degrees. Okay, our second example then. So we've been given another quadrilateral here. So we're told this one's 62. We've been given our right angle symbol for these two. So each of those must be 90 degrees. And again, we know the total adds to 360. So 360 minus the 62 plus the 90 and the 90. Now that adds to 242. So 360 minus 242 means that B is 118 degrees. Example 3 then. So this time we've been given a quadrilateral here, but we also have some extended lines, so we have some exterior angles as well. So we're going to need to use some of the other rules that we have learnt. So let's start off with angle C then. So here we can see we've got two straight lines that form across, so these must be vertically opposite angles. And we know from our previous lessons that vertically opposite angles are equal, so C is 112 degrees. For D then, we've got our quadrilateral. Total angles add to 360. So if we add up the three that are on the inside, so we don't need this one here. Remember, we're only looking at the quadrilateral. So if we add our three together and take it from 360, we will get D. So those add up to 285. 360 minus 285 is 75 degrees for D. And finally then we need to find our exterior angle E. So we can either use this straight line here or this straight line here. It doesn't matter which, but we know that angles on a straight line add to 180 degrees. So 180 minus 112 will give us our final angle of 68 degrees. Make sure you're happy with all of those examples and how we found those angles before we move on. So we're using all of the rules that we've used from all of the previous lessons, as well as our new rule that angles in a quadrilateral add up to 360 degrees. Okay, so your turn then. So pause the video, have a go at finding those missing angles in those quadrilaterals. Okay, so let's have a look at the solutions for those then. So our first one, A, is 100 degrees. For B, we have 110 degrees. C, 110 degrees. D, 103. Once we know D, we can use that to find E, which is 77 degrees. For this question, we can see they've both been labelled F, which means they must both be the same size. So we needed to do 360 minus the 80 plus 30, and then divide the answer by 2 to share it between these two angles. So F is 125. And finally, to find G, we're going to need to find this missing angle here first. So that missing angle was 110. And then we can use our angles on a straight line to find G, which is 70 degrees. Alright, so our key point from this part of the lesson then, the angles in a quadrilateral add up to 360 degrees, so make sure you've made a note of that. Alright, so we're going to have a look now then at special types of quadrilaterals. So we've just looked at irregular quadrilaterals that don't have specific names, but there are some quadrilaterals that have specific names and they're defined by different properties. So you need to choose from a square, rectangle, rhombus, parallelogram, trapezium, kite or delta, and see if you can name those 8 shapes. Okay, so our first one, A, then we can see that all 4 sides are the same length, and that tells us that one's a square. B is a kite. C, a rectangle. D is a parallelogram. E is the delta. F is a trapezium. Now it's a particular type of trapezium, an isosceles trapezium, so it's worth making a note of that. G is a rhombus, and H is an irregular trapezium, so we just call that one trapezium. Okay, make sure you're happy with those. It might be a good idea to draw those shapes into your book and to write their names underneath so that you know how to use them. Okay, so now that we know the names of the shapes, we're going to have a look at doing some reasoning. So can we work out which shape is being described? So pause the video and see if you can work out which of those shapes are being described by those sentences. Alright, so our first one then, I have 4 right angles and all my sides equal. So if we have a look at the shapes down here, shapes with 4 right angles. Well, we've got shape A, which was our square. We've got shape C, which is our rectangle. They're the only 2 that have 4 right angles, and we want the one with all the sides equal, so that's going to be the square. The second one then, I have 4 equal angles and 2 pairs of equal sides. So all 4 angles equal. So again, okay, we've got our square here has all 4 angles equal. Our rectangle has 4 right angles, so all the angles are equal there. Let's have a look along. None of the others have all the equal angles, and it has 2 pairs of equal sides. So that's going to be our rectangle. So we've got a pair of equal sides here and a pair of equal sides there, as opposed to the square where all of the sides are equal. Okay, for C then, I have one pair of parallel sides. Well, our square has two pairs, the kite has none. Our rectangle has two pairs. Our parallelogram has two pairs. Our delta doesn't have any. Our trapezium has one pair. Our rhombus has two pairs, and our other trapezium has one pair. So it must be a trapezium. So either an irregular trapezium or an isosceles trapezium, doesn't matter which one. Finally, for D then, I have no right angles and my opposite sides are equal and parallel. So we've discounted our square because that has right angles. Our kite does not have any parallel sides. Our rectangle has right angles, so that's no good. Our parallelogram has no right angles. Its opposite sides are equal and its opposite sides are parallel, so it could be the parallelogram. Our delta does not have any parallel sides. Our trapezium has only one pair of parallel sides. Okay. Our rhombus, both the sides are parallel. Okay, and there are no right angles and the opposite sides are equal. So it could be our rhombus, but not our trapezium. So it could be a parallelogram or a rhombus. So a rhombus is a special type of parallelogram, which is why it shares a lot of really similar properties. The only thing different between our rhombus and our parallelogram is that in our rhombus all four sides are the same length. Okay, so hopefully that's given you an idea of how we use the different properties of our shapes to be able to identify them. Okay, finally for today then, we're going to do some memory maths. So if you haven't done this before, what you need to do is to pause the video, spend 2 minutes, so time yourself, spend 2 minutes looking at the screen, looking at each of the shapes, how they're set out, the different markings. So just to remind you of the markings. Lines on the sides there mean that those are of equal length, so equal lengths and equal lengths here. The arrows tell us whether sides are parallel. The orange dotted lines give us the lines of symmetry, so mirror symmetry. And the diagonal lines here in black dots show us that the diagonals bisect. It means the diagonals cross over at the centre of their lines, so the lines are split in half. Okay, so we've got all those different markings and all of the shapes and their names. So you need to spend 2 minutes looking at it, seeing how much you can remember. Then you need to turn your screen off and on a piece of paper try to redraw the slide as much detail as possible. Then turn your screen back on and check how much you've remembered. Okay, so have a go at that now. Alright, well hopefully you've remembered quite a bit. The more times you do this, the more you will remember. Okay, so maybe have another go on another day and see how much you can remember then, and if it's a bit more than you've remembered today. Okay, well done. Thank you for working through that lesson. That's the last lesson in this unit. We will be moving on to a new unit next time.